Hello students, in this video we are going to see one typical and important example of normal and tangential components for a particle in curvilinear motion. That is example number 8. Read the statement. The y coordinate of a particle in curvilinear motion is given by y is equal to 4t cube minus 3t meters. So it is in a rectangular components. So the y coordinate is given. Also, the particle has an acceleration ax is equal to 12t meter per second square. If the velocity of the particle in x direction is 4 meters per second at t is equal to 0, calculate the tangential and the normal components of acceleration at t is equal to 1 second. So let us write the given data. So it is given the y coordinate of the particle y is equal to 4t cube minus 3t. The particle has an acceleration ax is equal to 12t meter per second square. The velocity of the particle in x direction, that is vx, is equal to 4 meters per second at t is equal to 0. So calculate the tangential and normal components of acceleration at t is equal to 1 second. Right? So starting with the given equations, y is equal to 4t cube minus 3t. Say equation 1. Differentiating this expression with respect to t. So it is dy by dt is equal to 12t square minus 3. Now what is dy by dt? It is vy. So vy is equal to 12t square minus 3. Say equation 2. Again differentiating this with respect to t. So it is dvy by dt is nothing but ay is equal to 24t minus 0. So this is equation 3. Right? Now, also given ax is equal to 12t. Say this is equation 4. Now, ax is equal to dvx by dt, which is equal to 12t. So dvx is equal to 12t into dt. Integrating, we get vx is equal to 12 into t square by 2 plus constant of integration, which we can find out from the initial condition. What is initial condition? At t is equal to 0. At t is equal to 0, vx is given as 4 meters per second. So putting t is equal to 0, vx 4, then we get c1, constant of integration is 4. Therefore, expression for vx is equal to 6t square plus 4. Say this is equation 5. Now, at t is equal to 1 second, at t is equal to 1 second, we have to find out vx vy, ax ay. So from equation 5, we get vx, yes, 6 plus 4, 10 meters per second, and vy from equation 2. See here, from equation 2, Vy is equal to 12 into 1 square, that is 12 minus 3, 9 meters per second. From equation 4, Ax is equal to 12 into 1, 12 meters per second square. And to find out Ay, from equation 3, here Ay is equal to 24 into 1, so 24 meters per second square. Now from Vx and Vy we can find out the resultant velocity, magnitude of velocity, square root of 10 square plus 9 square, and its direction alpha is equal to tan inverse 9 by 10. This is with respect to x. Similarly, the resultant acceleration, square root of 12 square plus 24 square, and its direction beta is equal to tan inverse 24 by 12. This is again with respect to x. So find out V alpha and A beta. So we have V is equal to 13.45 meters per second. Alpha is 41.98 degrees with respect to x. A is 26.83 meter per second square, and beta is 63.43. Again, this is with respect to x. Now we have the velocity and acceleration when t is equal to 1 second. Now that acceleration is to be resolved into two components, two perpendicular components, one in the direction of velocity, which is nothing but tangential component, and other perpendicular to it, that is normal component. So let us see. So now at t is equal to 1 second, velocity is in which quadrant? Here Vx, Vy both are positive. So velocity in the first quadrant making angle 41.98 degrees with respect to x. So this is the velocity with respect to x making an angle 41.98 degrees. And acceleration is in which quadrant? Being Ax, Ay both are positive, it is also in the first quadrant, but with respect to x it is making 63.43. So the acceleration is making an angle 63.43 with respect to x. Now what is the angle between the velocity and acceleration? Say theta. So theta is equal to 63.43 minus 41.98. That is 21.45 degrees. Right? Now AT, that is the component of acceleration in the direction of velocity, AT is equal to A cos theta, and the normal component AM is equal to A sin theta. So A cos theta, A is 26.83, cos 21.45, and AN, A sin theta, 26.83 sin 21.45. So after doing calculations, you get AT as 24.97 meters per second square and AN as 9.81 meters per second square. So these are the final answers. Tangential and the normal components of acceleration. Understood? Thank you.